Now that we've created a custom ROS2 message, the next thing we want to do is to use this message in a C++ executable. To do that, we open the terminal and then go to the workspace and then the package and the source code directory. So in the source code directory, we're going to create the C++ executable. Call it, just call it any name, counter.cpp. Okay, and then we're going to give it a permission to make it an executable file. All right, so now you can go back to the workspace and then open VS Code. Great. So what we want to achieve in this code is to be able to use the custom ROS2 message in a C++ file so that we can test our own custom message. Okay, so the way this executable is going to work is that, remember, there are 3 files inside the custom message we created, which is called message counter, and the files are the name, the state, and count. So we want to be able to use this custom files of these variables in our code to publish the count. So we're going to publish count from 0 to 9, and that's 10. So we're going to publish count from 0 to 9. When it gets to 9, then we want to change the state from whatever it is. If it's true, it's going to change the state to false. And if it's false, it's going to change the state to true. And then it's going to print out something for us to see that, hey, something is happening here. So we're going to use the name and call it probably robot. And then we're going to tell, okay, hey, robot, we're changing the state, or, something like that. So to start writing the code, the first thing you want to do is to include your header files. And the first header is this ROS client library for C++, RCL-CPP, while the second header file is going to have the name that corresponds to the message counter message that we created. So the message counter we created was under the total control package. So the convention is to put the directory where it is. So the total control, and then followed by the MSG, and then we have the message counter HPP. Now it's normal for VS Code to put a red squiggly line. It's because VS Code can actually find the path for this message. So we are going to create it, and it's fine. So the way you use your custom message file on the header file is to first of all write the name of the package. So the name of the package is total control, and then followed by the other directory, which is the MSG. Remember, the MSG is under the total control package. And then we have the message counter. From the file we created for the message file, we already know that message counter starts with capital M and capital C, and the message and counter are joined together. But when you want to create the header file in your C++ code, the way you do it is you make the M a small letter. If it's a capital letter, you make it a small letter. That's the convention. And then the C also becomes a small letter, and they are separated with underscore. Okay, so you separate it with underscore. So that's the normal convention. And then don't forget to put the HPP to show it's a header file that your program is going to refer to. Okay. Next is using namespace, using namespace std chronometer is a namespace std chronometer. Now, std chronometer is the one responsible for handling our timing, which we're going to get back to that later. So the next thing is to create a class called counter. You can call it any name. It doesn't have to be counter. So create a class called counter, and then which has the right or privilege to the CLCPP node. So we have a class counter with a node object. Okay, remember for your class to put the semicolon at the end. So now we're going to create the public and private specifier. The public and private specifiers. Okay, so this is where we put in some stuffs. So what we want to do for the private specifier is to create some object. The first is the publisher, and then we're going to create a timer object and our own object that will undo the message counter in the message file. So let's create a publisher object. To create a publisher object, use the RCL-CPP, then publisher, and then you put in the type of message that your publisher is going to use to communicate. So in our own case, we're using a custom message that we created in the previous lesson. So this custom message is having, this publisher is going to have the type total control, and then the scope operator MSG, scope operator again, the message counter. All right, then we follow it with the shared pointer, and then the name of the publisher we're trying to create. So the name of the publisher, we will just call it publisher underscore. Okay, that's the name of our publisher. So once again, this is how you give it a type. The type is always, the name of the package, and then remember it's under MSG, and then we have the message counter. So you can refer to the previous lesson to see the file structure of your message file. So the next thing we want to do is to create an object for the timer. So we call it CLCPP timer base, and then shared pointer, and then the name of the timer object, which is timer underscore. So while the last thing we want to create is the total control MSG, and then message counter. So call it MSG underscore counter. So we're creating an object that is of type total control message counter. Now, while we're doing this, we're doing it because we have a structure called message counter, and inside that structure we have three variables, which is the name, the state, and then the count. So we are creating an object to access the structure message counter. So it means that this MSG counter can access the three variables we have inside the message counter message file. So with these, we can say msg counter.name, msg counter.state, and msg counter.count. So these can access all the three variables inside the message counter structure. Now let's go back to the public specifier. For the public specifier, we'll start by creating a constructor, which is called counter. Of course, because the class is counter, the constructor must also be counter. Okay, so we're creating a constructor that can handle the node object, and then we pass in the name of the node. We can call this any name, so I'm just going to call this node message counter. So this way we're creating a node called message counter. Then inside our constructor, we want to put a whole bunch of things. Let's start writing some code. The first thing we want to do is we only created the publisher object. We haven't actually created the publisher itself or the essence of the publisher. So we're just going to say publisher underscore, which is the object we created. We want to put something inside, and what we want to put is this, which stands for the node. So whenever we use this, we're referring to the node. Then we're saying create publisher, and when you want to create publisher, you have to put in the type of message that a publisher is going to use. So the type is total underscore control, scope operator MSG, scope operator message counter. Okay, message counter. Then we pass in two parameters. The first is the topic that we want to publish to. So we want to create this topic now, and we're just going to call it count number. So we're creating a topic called count number, and we're passing the QoS of 10. Remember, QoS is quality of service, and by default, the quality of service for publishing subscriber is 10. So then we're going to create message counter. So the first thing we want to do is to initialize our variables. So we initialize the count to 0, initialize the other one, which is the state to false, and then we want to initialize name to robot. Remember, these are the three variables inside the message counter file. So we initialize it to robot. Yeah, that's all. So let's move on to creating a Lambda function, which is going to handle whatever we want to publish. So I'm going to create auto pub count. So let's just call it the publisher count. It can be any name. Then we'll create a Lambda function, which says this, or the lambda expression, you know, whatever. So it's the same thing. So now we want it to do some stuff for us. So the first thing we want to do is to print out some certain information. We always want to say std cout. That's how you print out in C++, or one of the ways you print. So counter is, then we can put in what we want to print out. MSG underscore counter dot count. So for instance, the first variable, the first instance of count is 0. So this code is going to say counter is 0. And then we end the line, std end line. Then we also want to tell the state of the code. So we say std cout is state is, then we pass in the state. Remember, the state is msg underscore counter dot state. So if it's false, it's going to tell us that it's false, end line. So if it's false, it's going to tell us state is false. And then it keeps going on and on, keep publishing. Counter is 0, state is false. Counter is this, state is false. And so until a certain condition is met. So, but before that, we want to do something. And what we want to do is to publish, because without publishing, nothing is just going to happen. It will keep trying to increment, but then it's not going to be shown on your screen. It's not going to be published to the topic. So you have to publish what we have. And to publish, you pass in your publisher object, which is publisher. And then it has access to publish. Then the question now is, what do you want to publish? So you put whatever you want to publish inside this parenthesis. What we want to publish is MSG underscore counter. Now, when we say MSG underscore counter, we're saying that it's going to publish MSG underscore counter.count. It's going to publish MSG underscore counter the state, and then it's going to publish MSG underscore counter.name. So the main word is the MSG underscore counter. So if you just want to publish just one of these things, you can put it there and say MSG underscore counter the state. Okay, that's the only one you want to publish. But in this case, we want to publish the 3 variables or the 3 messages. Okay, so after publishing, then we want to increment count. To increment count, just say MSG counter the count and then increment it. So basically what we're saying is, at first it's going to tell us counter is 0, and then it goes to the next line. It says state is false. Okay, we can decide to change state to true. It doesn't really matter. So it's just going to say counter is 0, state is false. So, and then it's going to publish the message that we just created. So after publishing it, then line 24 or line 23 will increment counter. So it's just going to add 1 to counter, and then counter becomes 1. So the next thing it's going to publish again is counter is 1. So, and then it keeps going on like that. State is still false, counter is 2, then state is still false, and then it keeps incrementing counter by 1. So, and that's what this code is doing here. So now we want to put a condition to say that, you know what, if counter is equal to 10, then we want you to do something, which is what we're going to put here. So we can just say if MSG underscore counter dot count is false, sorry, is 10, then we want to do a whole bunch of stuff. So the first thing we want to do is to say std or let's just say what we want to do first is, if counter is 10, then we want to make sure that counter is changed to 0. So we're just going to say MSG underscore counter dot count. So make counter 0 and then change the state. So I'm just going to say MSG underscore counter dot state is equal to not MSG underscore counter dot state. So now what that is doing is just a logical thing. So it's just going to take state. So this exclamation mark is just changing the state. It means that if state is false, it's going to change it to true and then store it back into state. If state is true, it's going to change it to false and store it back into state. So that's just what that is doing there. And then we want to print some stuffs out. We're just going to say stdc out. Then we want to print hey, hey, robot. Yeah, so let's just say, hey, robot. But to say, hey, robot, remember, the name is already robot, so we don't need to type robot. We can just say msg underscore counter dot name underscore counter dot name. And say, hey, robot, starting again. And then remember the state has changed, so we can just also print out that the state has changed. So we can just say state changed. Okay, state changed. And okay, so basically what this is just gonna do is to check if the counter is 10. So when the counter is 10, it's gonna reset the counter to 0. And when it resets the counter to 0, it's just gonna change the state of the counter. So if the state is false, it's gonna change it to true. If it's true, it's gonna change it to false. And then it's gonna show us an output here saying, hey robot, starting again. And then it's going to tell us also that the state has changed, so state changed. But if the counter is not 10, it's just going to keep on, telling us that counter is 0, counter is 1, counter is 2, and so on like that. It's just going to keep on telling us that. But then we need to tell the timer the rate at which this message should be published. So to do that, we're going to use our timer object here again, and then say, this create wall timer, and then the question is, for how many seconds? This is where the chronoliterals comes in. We're going to say 1s, comma, and then pub underscore count. So we're telling the timer that to publish the count, this count in line 17. And remember, what happens in this count is line 17 is what is going on in this lambda expression or lambda function. So this is a lambda function. So basically, it's just going to run this code every second rather. So it's going to run the code every second. So that's the PUB count. It publishes PUB count every second. And that's just going to tell us counter is 1, then wait for the next second. Counter is 2, the next second. Counter is 3, and so on like that. Okay. So there's something we need to do to the state. Yeah. Now this state in C++ is just going to tell us that the state is 0 or 1. So that's how C++ handles the state. It's just when it's false, it's 0. When it's true, it's 1. So this is going to give us a kind of integer output. So, but then we need a string output. We need like true or false instead of 1 or 0. So to do that, there is something called bool alpha. So we're just going to say std bool alpha, and then so the bool alpha is going to take whatever is following. If it's 0, it's going to convert it to false. If it's 1, it's going to make it true. All right, now we need to wrap up our code. To wrap up this code, we go to the main function. We create the main function into main, which takes in 2 parameters. The first is int, there are 2 arguments, int argc, and then we have char pointer argv. Now we call the RCL CPP again, the ROS client library for C++, and then we say init. without if you do not initialize the node, it's not going to work. ROS is not going to know what to communicate to. It's not going to understand the node to communicate to. So you always have to initialize your node, and then you run the RCL CPP spin. So what do you want to spin? Of course, the spin is just going to keep your program running. So that's the function of the spin, to keep your program running. Then say std make underscore shared, and then you call your counter class. Okay, then followed by the RCL-CPP shutdown. So the RCL-CPP shutdown is always there to note whenever a process is trying to terminate your node. So a process like Control-C on your keyboard. So when your node is running and then you press Control-C, shutdown will just, kill whatever is happening and just make sure the old node, the whole thing is shut down and there's no more communication to the RCL CPP client library. Okay, next thing is to prioritize on 0. Yeah, hopefully this code is fine and nothing wrong with it. So the next thing to do now is to go to the CMake list. So we need to set up the CMake list to be able to use this code. All right, so you go to the CMake list, which is this here, and then so you want to add some a package called the total control. Now because our message file is using the total control package, we need to add it here. Total control required. Okay, so we're saying the total control package is required for this node to run. So we have to put a total control package there, and then followed by the executable. So we need to add the executable also. We do that here. Add executable. Now, whenever you do add executable, the question is which executable you want to add. So we're going to call our executable count. The executable we want to add counter, but then where is counter? We give it the location, just counter. Let's see. Now I think I need to explain that again. So when you use add executable, the second argument in the parentheses is the location where your executable file is. So our executable file is under the src folder, and then our directory, and then we have the counter.cpp, just this counter we created here. But then this other counter can be anything, you can give it any name. So it's more like an alias to the counter.cpp. So instead of calling counter.cpp, we can just call counter directly. So that's the executable we want to add. And then we need to add the target library, the amend target dependencies. So we add the amend target dependencies. The way the amend target dependencies work is this: it's first take the executable we're adding, the alias for our executable, which is counter, and then it runs the RCL CPP. Not even like alias, it's actually the executable here. So it's actually the executable. So the counter is the executable, and then it's it depends on RCL CPP, the ROS client library for Python. What else that our code depends on? It depends on the total control package. So we need to add it there. Most times, what is on your header file is what your amend target dependencies is going to use. So our header file uses the RCL CPP, and it also uses the total control package. So it's just required for this thing to run, and then we can add it there. Okay, so then we need to install this in our C++ executable. So we've added the executable. Now let us install the executable. To install the executable, just come here and add the counter, and boom, that's all. So that is all we have to do. Remember to always save your package or save your code or workspace. Okay, now we go back to the terminal. So what we do on the terminal is to build our package. To build the package, we type colcon build. Now, if there is any error in the code you've just written, the colcon build is going to fish out the error and tell us that there's error in, it can even go to the extent of mentioning the line numbers where the errors are. So when you run your colcon build, it's going to build the package. We have errors, we're going to know. Okay, we have error. All right, line 22 of our code. Let's go back to the code. Line 22. Oh, we forgot to put semicolon. And then line 23 also, we forgot to end the line. So I'm just going to put std end line. Okay, std end line. Yeah, that's fine. Let's go back and run build our workspace again. All right, so colcon build is successful. Now, when colcon build is successful, the next thing you want to do is make sure that you source your workspace. So I'm just going to source the workspace right now. Yep, workspace sourced. Next is to test the code. So the code, we're going to test it now. And to test it means we're going to run the node, which is ROS2 run, then the name of the package, followed by the name of the node. The name of the node we want to run is counter. Remember, we created counter in the C make list. Okay, so we're going to run it now, and let's see. Okay, its counter is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it starts again from zeros, and it tells us, hey robot, starting again, state changed. All right, it seems our code is fine and cool. Okay, you can see it start counting from 0 to 9, and then when it gets to 10, it resets counter and then tells us that, hey robot, starting again. All right, so that is how you can create your own message file, a custom message file, and then use that custom message file in a C++ executable. The next thing we're going to do is to write the same thing for using a Python executable.